Hello, welcome back to another episode of Rachel Teaches Math. Today I'm going to be going into graphing quadratic equations in Vertex Form using transformations. So far you have experience working in standard form, and most of your graphing has come from finding a table of values and graphing the coordinates from there. So we're going to go from standard form to vertex form. Now in vertex form, that's essentially your best form for graphing. It has all the information that you need. In a later video, I'm going to teach you how to convert from one form to the other, but for here, we're just going to look at what each of the pieces means. Hopefully, you remember what A stands for. It has the same meaning as A in your standard form equation. That represents your growth rate or your dilation, how quickly your function is growing. I'm going to say this is your dilation, which means it's either growing faster, dilation, or slower. Within the parentheses, H and K represent a coordinate. So it's the coordinate of your vertex. Now, hopefully you know in a quadratic, your vertex is your starting point. So let's say we have HK here. And then I know where my quadratic is beginning, and I use the growth rate to figure out where it's going to go next. Some important things to note before we start an example is that in a typical quadratic, your growth rate from the vertex goes up 1 over 1 to another coordinate, up 3 over 1, up 5 over 1, and that continues. So I usually write that out as if A equals 1, if your A value is 1, and your growth rate is 1 over 1, 3 over 1, 5 over 1, 7 over 1, and that will continue. So last piece before we do an example, it's x minus h. So that means whatever your vertex is, whatever your x value is for your vertex, it's the opposite within the parentheses. Okay, and then make sure you square it. Our first example, I'll remember I'm saying this is in the form A times x minus h squared plus k. Off to the side, I'm just going to write down some key information. 1, I know my growth rate. I know it's growing 3 times faster. So my A value is -3. Okay? This actually gives me 2 important pieces of information. 1, that your growth rate or your dilation. 3, it also shows that it's negative, meaning if you typically open up, we're going to be opening down. So this is a reflection over the x-axis. The last piece I'm going to look for is where is my vertex? So if it's x minus 2, that means my x value has to be a positive 2. And then -4, that means that your y value for your vertex is at -4. So I just write the vertex is at 2, -4. From there, it's pretty straightforward, okay? I'm gonna find 2, -4. And I know this is my starting point for my quadratic. Now, typically, like I said, a quadratic would have a growth rate of 1 over 1, 3 over 1, 5 over 1. But that is if A equals 1. In this case, A equals -3. All you have to do is multiply each of your numerators by -3, and that will tell you exactly what direction to go from your vertex. So I'm going to actually go down 3 over 1, down 9 over 1, and then down 15 over 1. So let's start from your vertex. Now, unfortunately, this grid is not large enough to get too much information plotted, but you'll get the point. From my vertex, instead of going up 1 over 1, I'm going down 3 and to the right 1, and a quadratic is symmetrical. So I'm also going to go down 3, left 1. My next coordinate would be down 9. I'm going to go off the grid. I'm going off the grid. All right, so I'm going to go down 9 which would be somewhere around here, and then over 1. This is more of an estimate. I don't recommend this. Don't try this at home. And then we can connect our parabola. Okay? Let's try one more example. Hopefully this one will fit. So, like the last one, this is also negative. My A value is -2. So I'm gonna go right into it. If A is 1, I'm setting up my 1 over 1, 3 over 1, 5 over 1. I recommend you do this for every single quadratic that you're graphing. And then for the next one, my A value is now -2. So take each numerator and multiply by -2. So I'll have -2 over 1, -6 over 1. -2 times 5 is -10 over 1. My vertex, which is my starting point, is at, now go back, it says x plus 5. I'm going to use the opposite x value. So it's going to be at -5, -3. This is your negative h value, and this is your k value. Okay, let's plot our starting point. -5, -3. All over here, -5, -3. And then from there, I'm going to use my growth rate of down 2 over 1. So I'm going down 2 over 1, put a dot. Down 2, left 1, put a dot. Down 6. Oh, great grids. Now, I probably would have, if you were given a graph and it's already labeled, like this already says -2, -4, -6, I may have changed the scale and just made this -4, -8, -12 to be able to fit more in there. But hopefully you get the point. So I'm going to go down 6, which we got here, and then over 1, down 6, and left 1. And then you have enough information to plot your quadratic. I usually recommend your vertex and then 2 additional points on each side. Even your vertex and 1 additional point on each side is enough information. So hopefully that helped. Again, if you liked the video, make sure you like and subscribe to Rachel Teaches Math and turn notifications on because I'm going to be making videos frequently. Bye.